Good morning, good afternoon. I am so excited to start this webinar, and as people have been rolling in, giving them a couple minutes to connect. I want to welcome you to the webinar. I'm Jeffrey Palermo, and I'll be your guide through today's webinar. I know your time is really valuable, and so I appreciate you spending it with us. And one of the logistics that's part of this webinar is a Q&A window, and there's also a chat window. If you would like to ask a question during the webinar, I invite you to do that. And I'm pretty good about working it in to the content of the webinar itself. And I'll try to do that. But my commitment to you is that I won't close the webinar unless I've been able to work in all of those questions or answer those questions. And so also, if the audio is coming through loud and clear, I'd appreciate it in the chat window, somebody helping me out and just saying, yep, audio is great. I want to make sure that everybody can hear really well. And if you have some colleagues who were not able to come but really wanted to, for those of you here, we are going to be providing you with a link to a recording of this, so you'll be able to share it with your colleagues. So let's go ahead and dive in and get started. And this is a DevOps Jumpstart for new .NET applications. And I'm the Chief Architect of ClearMeasure. We're a DevOps-Centered Software Engineering company. We're based in Texas, serving the broader United States and sometimes abroad. And my hope for you is that you're going to take something away that you can apply in your team to help you with your new project, and that you cannot spend the agile iteration 0, an entire iteration just trying to get started, but you can get started on the actual features that you need in the software, the actual software capabilities much sooner, and just get a start right off the bat instead of spinning the wheels for several weeks, getting the environments in place and getting the build and the deployment and static analysis and testing and all the things that are absolutely necessary in a DevOps environment. So let's go ahead and dive in here. And we have some things we'll share along the way. But the agenda for today is as follows. We'll talk about the objective that we're going after. We'll talk about some of the things that provide a challenge, and then we'll talk about two things that everybody needs. One is speed, the other is quality, and then we'll share some results that we've been able to get for our clients, possibly some next steps that we can help you with. So one of the things that we'd like to give you is a copy of our latest book. And this book, the manuscript is done. It's actually in the production process. You won't find it on Amazon yet, but we'd love to give you a free preview edition of our book, .NET DevOps for Azure. It's about 270 pages. And it launched at the Microsoft Build Conference. We distributed 400 copies of the book there. Just go ahead and email me directly for a free ebook version. We'd be happy to give you an ebook version just for attending today's webinar. And you can also go to the book manufacturer directly, lulu.com, and search for .NET DevOps if you'd like to order a print book and drop ship it straight to you. So that's available. All right. Also, another resource that might be useful is my podcast. I'm the host of the Azure DevOps podcast, and actually the show out this week is I interviewed one of the co-hosts of the .NET Rocks podcast, Richard Campbell, and he's out there this week. And in a couple weeks from now, the actual language designer of C# was a guest we recorded yesterday, Mads Torgerson. And we talked about C# 8 and what's coming up for C# 9. There's so many brilliant guests on the podcast. I highly encourage you to subscribe. You can do it on your iPhone, Android, any podcast directory, it's there. All right, so let's talk about the objective that we're trying to go after here with a DevOps Jumpstart for new applications. We don't want to take a long time to get going. We want to get to productivity as quick as possible, and we want to have a high speed to launching our product. If we're creating a new application, even if it's creating a new microservice that's a part of a larger system. We want to get going really, really quickly, and we don't want to take a lot of time. Okay. There are some challenges, and some fall into the vein of just complexity. The logic could be complex. The scale of performance characteristics that we need, the nature of the data could be complex, and sometimes the architecture itself, or figuring out the architecture. And there's so many choices to be made at the beginning of a project. You don't even have any working software. You don't have any code. Maybe you've drawn some things on the whiteboard. Maybe some of the team members have created some assumptions about the architecture, but they're not proven. And maybe the rest of the team doesn't agree. And so there's so many choices. There's a breadth of technologies to choose from. And the guidance out there says it depends way too much. And by looking at just the attendee list of this webinar, which by the way, I'm blown away by the interest, but just the number of software leaders we have on this webinar, all the way from technical executive management. We see some architect titles, some lead engineer titles, and run the gamut. You're responsible for equipping your team and serving in a leadership role. And so you need to get started quickly, and you need to navigate those choices. Now, on top of that, there's a macro situation that's going on in our industry. This graph right here is from the last Stack Overflow development survey. And we know Stack Overflow skews heavily to the Microsoft platform, which is relevant to all of you on this webinar, but we see similar numbers across the industry at large. And what we're seeing here is that over half of all of the people in software engineering have 0 to 5 years of experience. We don't have a typical bell curve. We have such a huge growth in the industry that we have this type of curve. And maybe, in a decade or two, it'll start evening out and we'll see the bell curve once again. But we have a macro trend going where there's so many new entrants to the software world. And if you're in a leadership position, you need to keep this in mind and take special care to equip the members on your team, and not expect that they're going to be able to put this environment in place for themselves. Okay, so that's just something we have to think about, because there are really, really smart, motivated younger people, like we see on the graph, 0 to 5 years of professional experience coming in. And if you have some of those on your team, you need to take special care to make sure that they're equipped properly and channel that motivation and channel that energy so that it's aligned with the business objectives. That's just something to keep in mind. Now, is DevOps the solution? Well, the graph, the picture on the left is straight from Wikipedia. And this is probably the most common DevOps logo that we see out there in the industry. And I absolutely hate it. It gives the wrong impression. If you read the canonical DevOps text, the Phoenix Project, and the yellow book, the DevOps Handbook, and then the book Accelerate, then you've learned about the 3 ways of DevOps. The first one is flow, the second is feedback, and the third is continuous learning. And the organizational premise is to get rid of any boundaries between different teams or environments around a system. And, believe it or not, it's arguing for the same thing that Scrum argues for in the Agile movement, which is a completely cross-functional team. It's to equip a team with all of the skill sets and all of the capabilities necessary to do anything that's required around the software. And so DevOps says the same thing. Hey, have a cross-functional team. Have one team. Whereas this glyph on the left still maintains this dev team and this ops team. And, we say, oh, we're not going to throw it over the wall. But look what this graphic does. Plan, create, verify, package. Oh, throw it over to ops, release, configure, monitor, and then, but we'll add some funneling back of information to planning for dev. I don't like it at all. We need one cycle, and that's the graph on the right, where all of those activities are important. We want to spin around that cycle faster and faster. Plan, code, integrate, package, release, operate, learn, and then do it again, do it again, do it again. And so there's some infrastructure that is really important around the middle. That's the automated DevOps pipeline. But you notice how small we put that black circle. And that's because this process does spin around the automated DevOps pipeline as a hub. And we want it to spin faster and faster. So it definitely is the hub, but it's not the full story. All right. Now, this is the more complete model, and there's 5 additional layers that really need to be put in place from the very beginning of the project. And we'll go through those. And to correlate back with the macro trend of the huge growth in our industry and all of the new people coming into the industry, let's consider this analogy. There was a business owner that wanted to start an auto mechanic shop. And so he bought a beautiful piece of property on a good road, lots of good traffic, built a beautiful building thinking only the best will do. Goes to the local auto mechanic school, talks to the dean of the school and tells him what his plans are and says, I want to hire your top 7% of your next graduating class. Only the best will do. I've budgeted what the salary is going to require for me to be able to hire those people and what the pay needs to be. I want your best of the best. He buys some brand new tools and equipment, has them drop shipped over to the beautiful new building. Well, lo and behold, the graduating class, he hires them. And they're standing out in front of the shop, really skilled, talented, motivated new mechanics who are the top of their class. And he gives his pep speech and tells them how excited he is to start this new shop. And these new mechanics are looking at this beautiful equipment and new tools that's on crates in the shop and beautiful new building and location. And the new owner says, all right, team, the customers are going to come soon. We have a few days to get ready. Let's get to work. And he walks off proud of himself, grinning ear to ear. And the new mechanics of the shop, fresh graduates, top of their class from the local auto mechanic trade school, they look at each other with fear and terror in their eyes, trembling because they have no idea what to do. They were never trained in how to set up their own shop, their own environment. They were trained in an environment that was professionally set up for them. And that's the same situation that we have a lot of times in our industry. And so this model for a DevOps environment to jumpstart the new project, to jumpstart this team, is really critical to equipping your team to get to productivity as quickly as possible. And we call this onion DevOps architecture. Obviously, it looks like an onion. There's layers. And we're going to go through each one, and we'll dive into what you need to do in what order in order to get that, to get your team and get this new application to productivity and shipping as quickly as possible, and not futz around with just spinning your wheels, taking too long to get past your jumpstart phase, to get past the startup phase for this new application. Doesn't matter if you're an actual startup company or a really long tenured company just starting a new application. The same things apply. All right, so let's get into it. All right. Each of these layers, each of them must have a really good strategy, execute it with discipline, and measure so that you know if your strategy is the winning strategy. Okay, we're going to go through each of these layers in the order that's necessary for a brand new application. But when you think strategy, think plan, think choices. Let me give you a quick example. Let's say best practices. It's a really easy one. It's not the first one you start with here, but there's so many practices that have been labeled as best practice that it's logistically impossible to use them all. So your strategy is to actually make a choice. Which practices are you going to use? All right, make sense? Okay, so before we get into the layers, let's dive into this automated DevOps pipeline, which is at the hub of our application. Now, this is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy. It has continuous integration build and a 3-tier deployment pipeline, which, by the way, you'll never have fewer than 3 environments, even for simple applications or microservices. We've gone deep into the technical bits. And by the way, we go super deep into this in every chapter every chapter of my book, .NET DevOps for Azure. But this is the top 1/3 of an architectural poster for Azure DevOps services and integrated with Octopus Deploy. If your software depends on virtual machines, then Octopus Deploy is absolutely a necessity. It is the king of deployments on virtual machines. And for some simpler scenarios, deploying to Azure App Service or whatnot, sometimes you don't need that sophistication. It's still useful, but if you're deploying on virtual machines, unless you want to essentially develop a whole nother application just to handle the deployment and have a mess of PowerShell, just go ahead and reach for Octopus Deploy and integrate it with Azure DevOps Services. If you would like the complete poster here, because there's so much detail here, we don't have time to go into every aspect of the automation portion of the pipeline, but you need this. This is one of the critical things that you need to jumpstart your application. You need the ability to go from a change of source control to automatically trigger the build and package and automatically deploy against at least one instance of each of the 3 types of environments. You need the 3 levels of test automation, and we just put the URL to the high resolution PDF of this poster in the chat window. And so if you would like a digital copy of this poster, go ahead and click on that and download the PDF. You can take it to your local print shop, put it up on the wall, and just go ahead and reach out. If you need any help with the technical bits of this, we do Azure DevOps Services implementations all the time, Octopus Deploy implementations all the time, trainings on both, and we can get you going quickly. But you absolutely need this basic automation infrastructure. And by the way, if you go through the book, .NET DevOps for Azure, it has build scripts. It has a link to a complete implementation, complete working project that you can use as a template to jumpstart the technical bits of your application. But now let's talk about the process that we're going to go through before we get into the layers of the Onion DevOps architecture model. This is the DevOps process. Now you can call the things different. It doesn't matter. Rename each of these stages, but this is the DevOps process. And the first 4 things across the top happen before any code is written. And this process is meant to be feature by feature. It's kind of like DevOps is best when you use a Kanban style process, where instead of taking a huge set of requirements and trying to going through in a batch model, you take one software capability and you run it through in a first in, first out type of thing, type of process, and you take one feature at a time. So the Kanban style works really, really well with DevOps. And I encourage you to give it a look. And if you're already using Scrum and you like it, I would highly encourage you to stream the product backlog items in a more sequential fashion and shorten your sprints. Don't use 2 and 3 week sprints. Use 1 week sprints, and that'll get your regular process more compatible with DevOps productivity. So these first 4 are all about things that happen before hands go on the keyboard, before any code is written. And the first one, let's go one at a time, is conceptual definition. That means, what the heck is this? If you do requirements definition, then that's largely here. For a particular feature, not a whole slew of functionality, but just a particular software capability, what the heck is this? That's conceptual definition. Now, once you define what it is, what the goals are, the business objectives, what success looks like, what you're trying to accomplish, then you take that feature and you ask yourself in user experience design, you say, okay, if I'm a person trying to use this, what's my experience going to be like? If I need to actually go to a user interface, is it a 2 or 3 screen progression? And what do I need on each screen? So wireframes would definitely be part of this process. Screen mockups, determination of number of fields and labels and data types. And then once we understand how a person is going to interact with this software feature, then we go on to technical design. And that is with the input of what the heck this is, conceptual definition, and then user experience design artifacts that are, screen mockups and the like. Then we have to have someone to make the key technical decisions. What's the architecture that this needs? Are there any architectural changes for this feature coming down the line? If this is the very first software feature that's coming down the line, we want to look at it and the theme of the overall system and come up with our initial architecture. And I say initial because we want to use an iterative architecture process. And by the way, my favorite one, and I'll talk about this later, is Philip Christian's 4+1 architecture. It's probably still the best model for agile, iterative, and emergent architecture. But even so, we need to create, we need to decide all the technical things that are important. Are we going to bring in any libraries, build versus buy, NuGet packages? That's in the technical design realm there. And then once that's been established, before we're ready to assign it to someone to write the code, we need to come up with our acceptance criteria. Now, Scrum calls for this, but really the best type of acceptance criteria is some test scenarios. If we know what the user experience design is, and we know what the conceptual definition, the goal is, and we've come up with some technical design decisions and constraints, and we know the architecture of the application, then we should be able to come up with a list of bullet points that say, go to this screen or click this button and do this, and then expect that the application does something, expect an outcome. And right then, you've just designed a test. That's it. That's all it takes to design a test, a set of bullets. It doesn't have to be long. I mean, this can be communicated in just a handful of words, a simple bullet list. And that's all it takes to create acceptance criteria. And the best form of acceptance criteria is something with teeth, and that is a test. And that can be implemented. So now we take output from all four of these types of decisions, we give it to somebody who's going to write the code, and they have all of the information they need to write that code quickly. If any of these four different types of decisions are missing, then the developer, whoever that is writing the code, whether it's a single or a pair, they're going to have to create ad hoc decisions. They're going to have to make assumptions. They're going to have to fill in the gaps, and they may or may not make the decisions that you want them to. And so it's best to equip them with everything. Again, I don't care what you call it, but you need at least these four, right? After the code, now we push it to the Git repository. Pull request process is great. Short-lived branches. Then we want a automated build kicking off automatically based on that change, a continuous integration build. And then that continuous integration build should package up the components of the application, push it into Azure Artifacts, and then automatically we have our first line environment that is only for automation, do an automated deploy. And we call that the TDD environment because it is a specific type of environment. It's for automation only. And we run our full system tests that have been developed with the feature. And those are tests that require a fully deployed application. After that, we deploy to our manual environments. Common names of the manual type of environment are dev, test, QA, UAT, staging, situational testing, integrated system testing environment, DIT, SIT. All those names are manual test environments. And so that's the middle type. And then, of course, production. You can have as many of each environment type as you want, but you need at least one. Then once we're in production, we need to operate and support. And by the way, the technical design, that needs to specify what type of logging, metrics, telemetry that we are going to be able to implement and take advantage of in order to operate the system, all right? Because operating the system develops information so that we can plan future changes. All right, so that's the DevOps process. Now, let's go through the Onion DevOps architecture model in the order of the layers that you need to think about them when jump starting a new project. So let's go to team workflow first. This is the first thing you need to think about, all right? When you're starting up a project, you want to make sure that you have a single place for all work to flow through. You don't want to just have the defaults of your board with not started, in progress, done. That's not going to do it because some of the symptoms, if you've lacked this, is if developers have to keep their email open because work may be coming through the project tracking system, but it also might be coming through email. Work might be coming through Slack, things like that. in an ideal state, each work center or each stage of your process, it needs to be defined with clear tasks, definitions, standards of done, and clear accountability for who's going to do it. And Kanban is a really good pattern. Okay. So we want it to look something like this. Now, remember those first 4 things that you need to decide before development starts, before coding starts? It's right here on your Kanban board. Conceptual definition, user experience design, technical design, test design, all before development, all before coding. All right, those are often left out, and there's consequences because you're always in an ad hoc state. And oftentimes bottlenecks and slowdowns and long lead times happen in those 4 stages ahead of coding, or you might say something's ready to be coded, and then your developers are trying to fill in the gaps about what the user experience design should be, fill in the gaps about what NuGet packages to pull in, or build versus buy decisions, or design patterns, or fill in the gaps about when I'm testing this, how should it behave? What are the expectations for it? And so if you pull those out front, you're going to really speed up your team right from the get-go, because there's some people who are really good at writing the code, and there's other people that are really good at being your technical lead or your application architect in technical design. And there's analysts that are really good about imagining and figuring out what it would take to test it once it's done. And of course, you have people who are just really gifted at determining what the user experience should be. And so you want to make sure that you've identified those skills and you've allocated them properly. Okay. So that's team workflow. And you want to capture that. You want to have every one of these columns assigned to a role. It's okay for that role to be filled by more than one person, but you want it clearly assigned to a role. And then that gives you the ability to measure the wait times and the lead times for when a piece of work enters these columns. If you're using Azure Boards, it's a work item. If you're using the new, and I recommend it, the new basic template for Azure Boards, then everything is an issue, and you can just assign it to anybody. And you have a card, essentially, a digital card in one of those columns. All right, so that's team workflow. The next layer that you want to put in place here after team workflow is defect removal, which is quality. It's a recognition that there are going to be defects. Capers-Jones has aggregated some research about defects, and he's published a paper called Software Defect Origins and Removal Methods. Again, that's Software Defect Origins and Removal Methods. And he has some aggregate numbers, and for every 5 defects that are found in a piece of software, only about 1.75 out of the 5 come from the source code. About 2.23 out of every 5, that's almost half, come from requirements and design. And of course, by the way, about 10% of those 10% of all defects come from bad fixes, which is improperly fixing an existing defect. But you want to put in place your quality controls, your defect removal methods. Now, there's a whole lot of defect removal methods that you can choose from on the left. And by the way, pair programming is as much as we talk about it, and it's fun to do, and I absolutely love pair programming. As a strategic defect removal tactic, it is highly effective, but it is the most expensive one because it absolutely doubles your labor for everything. Now, there are 3 defect removal and defect detection techniques that are proven to, when combined together, that are proven to get a piece of software up to the high 90s in percentages for defect detection so that you can fix those defects. And those 3 are testing, which we're talking about all kinds of different levels of testing, including multiple levels of automated testing, static code analysis, and formal inspections. Now, in a DevOps world, the best implementation of a formal inspection is a checklist attached to your pull request process. So everything is done on a branch, a short-lived branch. And then once that pull request is submitted, the reviewer goes through a predefined team checklist as they review the code. They don't just review the code and say, oh, it looks good, or provide some subjective feedback. They go through point by point on an actual checklist and make sure that every change in that pull request complies with the standards of the checklist. That's a formal inspection. Great DevOps implementation of a formal inspection. And then for automated testing, you want unit testing, you want component level integration testing, both of those running in your continuous integration build. And then you want full system acceptance testing running in a fully deployed environment. That's why we call it the TDD environment, to invoke that test-driven development. And you call it the ATDD environment for acceptance test-driven development. Now, if we were to hone in on where a lot of those can go, that's the continuous integration build. And so we can think of the continuous integration build as a test. And in the vein of test-driven development, it gave us the pattern of arrange, act, assert. And in the early extreme programming texts and test-driven development books, there's a lot of talk and a lot of guidance around the arrange, act, assert pattern. And so a build is the same thing. And so to arrange and to prepare the environment, we need to clean up previous artifacts and temporary files. We need to stamp a version number. We need to, most of our applications are going to use a SQL Server database or data of some sort. We need to create that environment, create the database, and migrate the schema so that we have that database environment ready for use. Then the act portion is actually compiling, transition the source code into working software. Okay, now, does the software that was just created work? Well, let's assert. Let's run all of our unit tests that stay in process or in a single memory space. Let's run all of our component level integration tests to make sure that different components talk to each other, make sure that the web application can talk to the database and any offline jobs, and those things are talking together. If you have any queues, if you're using in-service bus and you have a distributed application, integration tests would test those boundaries. And then after that's done, after you've asserted that the build is good, then you run static code analysis, which will give you a lot of information about possible defects or problems in your code, things that could be improved. Now, some teams choose to classify the static code analysis as part of the assertions, part of the assert. If you have some rules where you want to fail your build, if the new changes in the code cause some of your standard code metrics to go out of threshold, then you can absolutely put static code analysis in the assert column and consider it an assertion and then fail the build based on that. Then after that, we're going to publish the test results. We're going to package up the components of the application into NuGet packages ready for deployment. And we're going to publish those over to Azure Artifacts. So that's what the continuous integration build needs to look like right from the bat. By the way, if you just want a configuration ready to go, by all means, go to the Onion DevOps Architecture project on our Azure DevOps Services instance. That's the project that the whole book is written about, .NET DevOps for Azure. The URL also is bit.ly/.NET DevOps project. And you can literally copy every bit of that project and use to jumpstart yours if you want. All right, let's talk about, we're in defect removal now. Let's talk about the pull request process and how that goes. So it starts with the specification of these acceptance tests ahead of coding, specifying the test scenarios. And then we change the code, run the private build locally, we commit the code, run the continuous integration build, we deploy. We deploy to that first TDD environment. The automated acceptance tests run. These are probably using Selenium or Cypress or some framework appropriate for your application to run from a user's perspective that full test scenario. And then when those pass, then we are going to create that pull request, and then that formal inspection is going to happen. Okay, that's the full loop on the formal inspection. Now, after that, let's come back to best practices. Now, we already talked about this fact that we have so many best practices, you can't use them all. It's impossible. All right, so you got to make a choice. Which practices are appropriate for this particular project, this particular application? Because you got to make a choice. Not everyone's going to be appropriate. You know the business objectives for this particular application, but you need those practices to be chosen, communicated well, put some controls in place. That's your strategy, and you need to make sure that you have a way to measure it so that it's not only being executed and they're sticking with those practices, but that those practices are getting you the results that you're looking for. Okay. Now, those practices are going to come into play right around development. So the previous column on your Kanban board is test design, and immediately after development is functional validation. And so you want to put in as much teeth into the implementation of your best practices in your test design as is practical, and your technical design for that matter. And then in your functional validation, how those tests are running, you want to try to find out if any of those practices are not being used. All right. Now, some of the practices affect deployments. And this chart here is the 3 environment types: our TDD type environment, our manual type of environment, which we commonly call user acceptance testing or manual testing, and then production. Now, there's a whole lot of techniques and a whole lot of tactics that are appropriate for running in that first line, first deployed environment where no humans are allowed than the other 2. And notice that there's nothing that happens in production that hasn't happened in at least one environment prior. So we never do anything in production for the first time. That is a DevOps tenet. You want a production deployment to be boring, old hat. We've done everything necessary before. And by the way, techniques like infrastructure as code allow you to provision environments that are exactly the same. And so you don't have to worry about things being different in non-production environments. And also, even if you've got a hugely hairy database that has a terabyte of data, there's products from Redgate that allow you to clone all of that data and even mask some of the data, or despecify and ambiguate some of the data so that you have a full and complete data set while still keeping your production controls in your production environment. So there's every tool available for tackling all of the difficulties. You just need to take these principles and get them in place for yourself. Now, I'll hone in on one thing around your full system acceptance tests. In Azure DevOps Services, this is what you're going to see. If you have full system tests being specified before coding, and then you run them, then you can actually see how it goes. So this particular view, and this is a sample application, there's 6. By the way, this is one of the testing views of the Onion DevOps Architecture project template that you can just pull down and use for yourself. And we've put in place 6 example full system tests. And on the right, we've actually taken a screen grab of the browser window while these tests are executing. It's a test robot pulling up a browser, navigating to the URL, and we can look at that more closely. We can see these text box and we can see the button. Now, it doesn't capture the browser border, but everything within the border, it captures, okay? And so we can even see if something's starting to go haywire and some people provide a report that something's not quite right, we can actually go back and look at all of the screenshots of our application as previous builds have been running all of these tests and pulling up the user interface and taking screen captures of all of the screens. I mean, how much manual labor is saved just from that alone? All right, so the next layer we need to think about is our architecture. We need to think long-term. What are we building? What is our architecture vision? Now, I talked about the 4+1 view model of software architecture. Philippe Christian from Rational Software Corporation in 1995 put out this white paper. You can Google search it, and it's a phenomenal PDF. Make sure that you read all the way to the end, because the last 25% of the paper really talks about how to do it in an iterative, emergent way, because you may have a long-term vision for the architecture, but you're not going to build out all of those architectural elements on day one. You're going to do it piece by piece and only as you need it. But you need to specify what the architecture is and have those things. Those 4 layers are physical, logical, process, and development. Physical is, how's it going to run? Runtime. Now, in 1995, we're all on physical servers. Now it's really the spirit of it is, how is it going to run? Okay. And then logical is dependencies between assemblies and Visual Studio projects. The process layer is, how does data flow? What's the sequence of flow when data comes through your application? And then the development environment is, what's the structure of your DevOps environment? What is the environment like that's going to equip your team to develop, grow, and run and operate this piece of software. Now, there's so many ways that you can run any given application. You have to choose your runtime architecture, and you could run it in your on-premise data center. You could have hosted VMs somewhere in rack space. You could have Azure VMs, or next step along, you could use Azure Container Service or Kubernetes with Docker containers, which is a slice of an operating system if you're on .NET Core and go into Linux. Or you could go platform as a service and use Azure App Services, where you don't even care about the operating system. You don't even care about the container. You just say, hey, run my stuff. And SQL databases live nicely in that environment. Definitely .NET applications run nicely in that environment. So there's a whole spectrum, but you need to make a choice. And that is architecture. Even before a single line of code is written, it's often important to make these types of decisions right up front, or at least for the first module that you're developing. Okay. And if you determine that you're going to use a decentralized overall system architecture and not build a monolithic Visual Studio solution with lots and lots of different running processes, then you don't have to choose a single runtime architecture for every application. It can actually be different. So it kind of makes your life easier. Now let's consider a particular example. You've got a Visual Studio solution with an ASP.NET web application, an offline job, and a SQL Server schema. All right, well, we got a lot of choices. One choice is to run that ASP.NET web application inside Azure App Service. You have other choices, that's one, but you need to make the choice. Your offline job, well, are you gonna run as a Windows service, a scheduled task, a web job, or you can run it as an app service function, Azure function. That's a choice, but make the choice. Your SQL Server schema, where's it gonna run? Is it going to run in a basic throttled Azure SQL instance? Is it going to use Azure managed instance where you have the full power of every bit of SQL Server? Or are you going to actually spin up VMs in Azure and create your own SQL Server cluster? You need to make a choice, okay? And then your acceptance tests. Most of the time, that's just an in-unit or an X-unit test suite, and that can run straight on a hosted build agent. But again, for running your tests against a fully deployed environment, you need to think about that. Make your choice. If you just make these choices, some of these choices really fall in line quickly, but without these choices, your team is going to try to write the code, and then they're going to be confronted with a choice that wasn't made, and they're going to either stop and start the conversation then, or they might just make an assumption and run with it. All right, there's also some tried and true patterns of code segmentation that kind of work really well with DevOps, the DevOps process, and the common DevOps tooling that's available out there in the industry. And there's some rules where if you break them, you may argue you could technically get things to work, but it's on you. You really don't have any help from the ecosystem. So if you want to fall into the pit of success, if you want all the tooling to work really well for you, then follow this chart right here when it comes to system segmentation. All right. A software system can be composed of multiple applications or multiple services, might even call them multiple microservices, multiple running code bases, okay? But we'll call them all applications. So an overall software system has multiple applications. Each application needs its own Git repository, and each application needs to be owned by one team. It's okay for that team to own all of the applications in the system. It's also okay for the overall system to be so big where you choose to organizationally have one team responsible for each application and then just coordinate via APIs. That's your choice. But don't put more than one application in a single Git repository, and don't have more than one team be changing code in a single Git repository. You're kind of breaking one of those rules where all of the tooling and all of the patterns out there in the DevOps environment are going to be hard for you if you try to break one of these relationships. Okay. And for a single Git repository, everything that's in that Git repository should be built by one build script, by one continuous integration build. And then for whatever applications in that Git repository, you would package it up according to components. So it's okay for one application to have a web application, 2 offline jobs, and a SQL Server database, as long as it's one application. It's built together, changes together. You think of it as a thing and it deploys together. If you were to say that one of those jobs really needs to deploy at a different cadence, then it means that that job needs to be considered a separate application. Okay. So when you're thinking about microservices, that's how microservices get their own Git repository and they get ownership over their own data. And so if the data is going in SQL Server, the microservice owns its own schema with just the table that it needs. Okay. And then the microservices integrate with each other via well-known and published APIs, whether they be messages over a queue or HTTP APIs, or even consuming a NuGet package that's published from another microservice. Okay. All right. So follow these rules and your life is going to go easier. And this is a huge help when jumpstarting a new application. And by the way, this diagram is in the book, .NET DevOps for Azure. Now, last layer we're going to talk about is cloud operations. This is how do we run the application and how do we operate it. Okay. Until we run it, we're not really providing any value to our people, to the users. And there are things that we need to bake into the architecture to make it easier to support, to make it easier to operate. And that is telemetry, essentially. We'll talk about that. Now, we also want to create an environment for capturing all kinds of telemetry from every piece of runtime of our application. So this particular application has 3 things that are running in a production environment and 1 thing that's running in pre-production environments. So in Azure, we use application insights. But regardless, the principle is to centralize a place that gathers all of the telemetry information from everything that's running so that you can query it and derive meaning, okay? And so in Azure, that's an application insights service. You're going to need an instance of application insights for every environment type, okay? You don't want to mix your application insights production with pre-production because there is no segmentation by environment in application insights. If you try to force it, you're on your own. Yes, you can technically put in tags and attributes on every statement delineating what environment is, but then in every query, you're going to have to segment by environment. Now, you fall into the pit of success by having an application insights instance per environment type. And depending on your case, if you have a production environment per customer, if you are a single code base, multiple instance type architecture, you may have application insights per customer, but you need to think about that segmentation and think about how you're going to get information out. And you can also, at a greater level of aggregation, funnel everything into log analytics, and log analytics can take data from all kinds of historical and legacy text files, all kinds of different places, and put it all together. Now, let's talk about telemetry because we want to be able to observe what this application is doing from day one. We want to be in production the first week. Now, the first feature may be only the shell of our application UI, or it may be a login page, or it may just demonstrate that we can even have a health check API that's deployed and validating our environments. Okay, but we have something in production. So if we have something in production, we need to be able to check and see how it's going. There are 3 types of telemetry that you need to design from day one. You probably already know about logs, and this is free-form information that is normally 1 line of text, okay? You want to funnel all of your logs into App Insights, but then the 2 other types of telemetry that you want to make sure is designed into your application are metrics and events. Now, metrics are numerical, okay? They are not a full line of log. It is a number, it is a decimal, it is numerical. It is something that is compatible with aggregate functions, sum, average, min, max. You can aggregate it and then split it over time so you can see how the number changes week over week or changes by region that the user is in, okay? Events are pre-named tags. They are well-known tags such as user login, failed user login, successful user login. And because you tag them, you can count these things and you can group metrics by events. All right. Now, a lot of you have probably designed business intelligence capabilities into your software to enable your users to have star schemas or data warehouses, and then layer on Microsoft Power BI or Excel Power Pivot or Tableau reports or line graphs or things like that, and you're probably familiar or you've used the Kimball data warehouse methods. And if you've learned about star schemas with dimensions and facts, then you already know this, because dimensions are events and metrics are facts. And you are essentially equipping yourself and equipping your team with a data warehouse of information whereby you can use run-of-the-mill business intelligence tools, connect it to it, and derive information for how your application is behaving, because you've built up your own database about what's happening. Okay, pretty cool, right? So that's telemetry, logs, metrics, and events. Now, application insights, man, it automatically just grabs so much information and throws it in automatically. If you're using Entity Framework and SQL Server, just by adding the NuGet package and configuring a few things, you automatically get tracing of every single interaction between your application and SQL Server and pulling through those reports. So you get tons of value from a technical perspective just by connecting App Insights right from day one. Now, obviously, the data and the parameters are not captured, but the structure and what the query is. Also, something that you want to do is put in release markers. Highlighted, this is the performance view. Obviously, there was only a little bit of traffic, but what I've highlighted, this green marker, denotes that there was a deployment at roughly 8 a.m. on that given day, and what SQL database dependencies had the most traffic, accounting for performance usage. And if you click on that in App Insights, then it tells you exactly what version was deployed then. Because if exceptions start peaking, if performance drops, it's really good to know, oh, this change kind of happened right after we deployed, version 1.0.705. Okay, it may be correlated, and you can link directly back to Azure DevOps Services for that. All right, so that is cloud operations, and those are the things that you need to think about on day one when jumpstarting your application. And with each of these layers, starting with the automated DevOps pipeline, then going team workflow, defect removal, best practices, architecture, cloud operations, you need to make your choices, your strategy, execution, and measurement. Now we've had results for so many people, and one of them is Best Egg. They're a lending startup, and we helped them get off the ground, jumpstart to market, and it was just incredible the impact that we've been able to make for them, and we'd love to make that impact for you. And you can find that story on our website, but I'll just play about a few seconds of this for you.
ClearMeasure was with us before we launched. From the time we initially did the project with them to launch was 4 months, and it was a rapid evolution of idea, the conception to reality, and they were a critical part of that.
All right, so the full story is on our website. You can go to bit.ly/project jumpstart story and learn more about that. But we want your team to be a completely self-sufficient, world-class team, and so we help with a variety of things to guide you through that and to elevate your team, elevate your process. Staffing companies want to place someone in your organization. Dev shops want to deliver code and create codependency. We want you to be self-sufficient. We want you to be world-class. And so we do a lot of project jumpstarts, inspecting your existing DevOps environment, reviewing your software architecture or advising on that, and also finding a DevOps plan for modernization to figure out how to get that legacy application to move forward for the next 10 years. So next steps, get the book, really. Get the book. If you're ready to reach out and give us a call, that's great. But just if you're planning your next project jumpstart, this provides a pit of success configuration right off the bat for a .NET Core application. you can go to bit.ly/.NET DevOps book or bit.ly/.NET DevOps project and use that configuration. I think that I worked in the questions that came in as I was talking through, unless an additional question pops up just now. But if you have any questions, then just reach out. There's my phone number, email address, and make sure to go to bit.ly/project Jumpstart story to see what we did for Best Egg and Marlet Funding in jumpstarting their system and how it really propelled them forward, because it's quite remarkable. So I do want to thank the people who submitted questions as we were going along, and I was able to kind of work them in as we went through here. And thank you for joining the webinar. My hope for you is that you'll be able to take some of this information and you'll be able to take it back to your team and lead them and contribute this learning and this information so that your next new application can get jump started in a really quick manner, and you'll have some really good speed to productivity and help it succeed. So thank you so much for your time. I'll leave this slide up for a little bit so you can make sure to get it, and we'll talk to you soon. Thanks.